talk about complements and conditional probability. So we're going to use complements when we see the words at least one. And we want to remember that the words at least one means one or more. The complement of at least one, everything that's in the sample space that's not at least one, is none. Okay. So we're going to go through a couple of, first just how we think about complements. So if event A is at least one of the 6 pens works, the complement, so here since we have at least one, the complement would be none of the pens work. Now, another way of thinking about this, if none of them work, all of them fail. Right? All of them don't work. So those are two ways to say the exact same thing. That would be the complement of A. The second one says, if event A is none of the students fail the class, so the complement of none is at least one. So we'd say at least one student fails the class. Okay, and just a reminder from earlier, when we're finding the complement, so when we want the probability of the complement, it's 1 minus the probability of A. So our procedure says that 4 students are each asked to choose a number from 1 to 3. So we're going to assume that they're choosing those numbers randomly. So the probability that at least one student chose the number 3, well, we're going to, whenever we see the words at least one, we're going to do the complement of none. So we're going to do 1 minus the probability that no student chose 3. So we'll do 1 minus, so the probability that the first student didn't choose 3 would be 2/3, because they could have picked a 1 or a 2, times the probability that the second student didn't choose 3 would be 2 out of 3. And we're going to do this 4 times because we had 4 students. So times 2 out of 3 times 2 out of 3. This would be the same as 1 minus 16 over 81. And if you put that in your calculator, as a fraction, you'll get 65 over 81. As a decimal, you'll get 0.802. Okay, now what if we wanted to do this for a much bigger number than 4 students? How could we think about this? So notice here when we had 4 students, we could also have written this as 1 minus 2/3 to the 4th, because we multiplied it by itself 4 times. So number 4 here, or this says, if there were 16 students, find the probability that at least one student chose a 3. So again, we want 1 minus the probability that none chose a 3. Now here, since we have 16 students, we'd do the same thing, but we would do 2/3 times 2/3 16 times. So we can write this much easier as 1 minus 2/3 to the 16th power. And if you put that in your calculator, you'd get 0.998. Okay, we're going to look at another example. So this is example 4. So it says, suppose your alarm clock has an 80% probability of working. To be sure you get up in time to take your big statistic test, you buy 4 alarm clocks, all having the same probability, all having an 80% chance of working. What is the probability that at least one of these alarm clocks will work that morning? So the probability that at least one works is going to be 1 minus the probability that none of them work. So we need the probability that each of them fails. So this is the same as 1 minus the probability that all fail. Now, if they have an 80% chance of working, they'd have a 20% chance of failing. So we do 1 minus 0.2 to the fourth, since there are 4 alarm clocks. If you put that in your calculator, we'll get 0.998. So with those 4 alarm clocks, you'd have a 99.8% of chance of one of the alarm clocks working. So our last problem here for complements says we have 10 cards, 6 spades, and 4 hearts. We want to randomly choose 3 without replacement. We want to know the probability that at least one of the 3 cards is a heart. So we're going to do 1 minus the probability that none is a heart. Okay, now another way of saying this, if none of them are heart, they're all spades in this case. Now we're not replacing them, so we need to remember that. So we're going to do 1 minus. So the probability that the first one is a spade, there were 6 spades out of a total of 10 cards. Since we're not replacing it, the probability that the next one is also a spade would be 5 out of 9. And the probability that the last one is a spade would be 4 out of 8. And if you calculate this, you'll get 0.833. So about an 83.3% chance that at least one of them would be a heart.